Integration using trigonometric identities. Some integrals involving trigonometric functions can be evaluated by using the trigonometric identities. So you should be thorough with all the trigonometric identities which we studied in 11th standard. These allow the integrand to be written in an alternative form which will be easier to integrate. Let us see the first method. Write down this in your formula notebook. Integral sine power mx dx or integral cos power mx dx, where m is even. To integrate such functions, use the identity sine square x is equal to 1 minus cos 2x divided by 2 and cos square x is equal to 1 plus cos 2x divided by 2. This is the method. Let me explain example 7, first subdivision. Integral of cos square x dx. We know integral of cos x. We don't know integral of cos square x. Don't write it as sine square x. So we use this identity because we have even power here. Cos square x identity in terms of cos 2x is 1 plus cos 2x divided by 2. By using this identity, now we avoided the power 2. There is no power for cos function now. Half is a constant. We can take it outside the integral. Now integral 1 plus cos 2x dx is easy to integrate. Integral of 1 with respect to x is x and integral of cos 2x is sine 2x divided by 2 and plus c. Exercise 7.3, we will do the first question. It comes under this type. Integral sine square 2x plus 5. We know integral of sine x. We don't know how to integrate sine square function. We have to use the identity. Here 2 is an even power. We are using the formula sine square theta is equal to 1 minus cos 2 theta divided by 2. Therefore, it becomes integral 1 minus cos of 2 times 2x plus 5 divided by 2 dx. Take half out. 1 minus cos of 4x plus 10 dx. Now we can integrate. There is no power for cos function. Integral of 1 is x and integral of cos is sine of 4x plus 10 and divide by the coefficient of x term. This is a linear function in x, so we can directly integrate. And plus c. Now let's do question number 10 because that also has even power. Question 10 and 11 we will do. Both are having sine and cos functions with even powers. Integral of sine power 4x dx. 4 is an even power, so we use the same identity. We can write sine power 4 as sine square x the whole square dx. And sine square x is 1 minus cos 2x divided by 2 the whole square. The denominator 2 square becomes 4, which can be removed outside, and 1 minus cos 2x the whole square. Let us expand. We get 1 plus cos square 2x minus 2 cos 2x dx. Now again this has to be done by using the identity. 1 by 4 integral 1 plus cos square 2x identity is 1 plus cos 2 times 2x will become 4x divided by 2 minus 2 cos 2x. So twice we are using the identity here. Now here we have 1, here we have half. We can add them. 1 plus half is 3 by 2. And the second term is cos 4x divided by 2. And the third term is 2 cos 2x into dx. Now each term can be integrated. 1 by 4 times 3 by 2 is a constant, so it becomes 3 by 2 times x. And integral of cos 4x is sine 4x divided by 4. 4 2s are 8. Minus, you have to divide by the coefficient of x term. 2 times integral of cos is sine 2x and divide by the coefficient of x, which is 2, and plus c. Therefore, the final answer is 1 by 4 times 3x divided by 2 plus 1 by 8 sine 4x minus sine 2x and plus c. To question number 11. This also has an even power for cos function. Cos power 4 2x. This can be written as cos square 2x the whole square. Use the identity. 1 plus cos 2 times 2x will become 4x divided by 2 the whole square. Let us expand. A plus b the whole square, a square plus b square plus 2ab into dx. Now we have to use the identity again for cos square term. Integral 1 plus cos square 4x is 1 plus cos of 2 times 4x will become 8x divided by 2 plus 2 cos 4x dx. Let us add the like terms and write. We have 1 here and half here, which becomes 3 by 2 plus the second term is cos 8x divided by 2. This 2 is common to both the terms, 1 as well as for cos 8x plus 2 cos 4x into dx. We will integrate. Integral of a constant is that constant times x plus integral of cos 8x is sine 8x divided by 8. So 8 2s are 16 plus 2 times integral of cos 4x is sine 4x divided by 4 and plus c. We can take 1 2 out. So 1 by 8 times 3x plus 1 by 8 sine 8x and sine 4x plus sine 4x plus c. Now we will learn the next method. Write down in the formula notebook. Integral of sine power mx dx or integral of cos power mx dx where m is odd. The previous method was where m was even. Now here m is odd, so split the odd power and use the identity sine square x is equal to 1 minus cos square x or cos square x as 1 minus sine square x. This is the method.
But if m is equal to 3, we may use this method, splitting the odd power method, or we may use sine 3x identity, which is easier. Therefore, sine 3x is equal to
3 sine x minus 4 sine cube x, from which we can write the expression for sine cube x. Sine cube x will be 1 by 4 times 3 sine x minus sine 3x. So we can replace sine cube by this, where there is no power for sine function. So we can integrate each term easily. Similarly, cos 3x formula can be used for cos cube function. Cos 3x is 4 cos cube x minus 3 cos x. Therefore, cos cube x is 1 by 4 times cos 3x plus 3 cos x. So this is the next formula. If the power is odd power, that is power 5, power 7, etc., you may use splitting the odd power method. Whereas if m is 3, this method will be easier using this identity, or you may use splitting the odd power method also. Let us do example 7, the third subdivision. Integral sine cube x dx. Let me use the identity. For cube function, identity method is easier. Sine cube x is 1 by 4 times 3 sine x minus sine 3x into dx. That is, we have used the formula sine 3x is equal to 3 sine x minus 4 sine cube x. So we have found sine cube x expression from this. If you notice, there is no power for sine function. So we can easily integrate and write. Integral of sine x is minus cos x, and integral of sine 3x is minus cos 3x. Minus of minus will become plus cos 3x, and divide by the coefficient of x, and plus c. Exercise 7.3, question number 4. Here also we have an odd power. The odd power is 3, so we will use the identity method. Sine cube formula is 1 by 4 times 3 into sine of 2x plus 1 minus sine of 3 times 2x plus 1 dx. Using this formula, we can find sine cube from this. See, now we don't have powers for sine function. Let us integrate. 3 times integral of sine is minus cos. It becomes minus 3 cos of 2x plus 1. 2x plus 1 is a linear function, so I can integrate. And divide by the coefficient of x term. Minus integral of sine is minus cos, so minus of minus plus cos of 6x plus 3. Divide by the coefficient of x, which is 6. And plus c, the constant of integration. We can take 2 out. The answer is minus 3 cos of 2x plus 1 and 1 by 3 times cos of 6x plus 3 and plus c. If you use splitting the odd power method, you will get a different answer. But using the trigonometric identities, we can prove that both the answers are same. Now let us learn the next method. Write down this in the formula notebook. If you have integral of sine mx into cos nx dx, or integral of sine mx into sine nx dx, or integral of cos mx into cos nx dx, or integral cos mx into sine nx dx.
That is product of sine and cos, or sine and sine, or cos and cos.
We will use the following identities. 2 sine A cos B is equal to sine of A plus B plus sine of A minus B, and 2 cos A sine B. Sine of A plus B minus sine of A minus B. Two cos A cos B is equal to cos of A plus B plus cos of A minus B, and 2 sin A sin B is cos A minus B minus cos A plus B. So use one of these identities. The left hand side you have product of two functions. By using these identities, it becomes either plus or minus, so easily we can integrate each term. Let us do questions using this method. See question number 2. Integral of sine 3x into cos 4x dx. We don't have 2 to use it, therefore we will multiply and divide by 2. We get half of 2 sine A cos B. 2 sine A cos B is sine A plus B plus sine A minus B. I am writing the formula here. 2 sine A cos B is sine A plus B and plus sine A minus B. Let us use this identity. It becomes sine of A plus B. 3x plus 4x is 7x, and plus sine of A minus B is minus x. 3x minus 4x is minus x times dx. And sine of minus theta is minus sine theta, we know. Therefore, it becomes sine 7x minus sine x dx. After using this identity, look at the function. We don't have product of two trigonometric functions. Here we have subtraction in between. So we can easily integrate each term. Half into integral of sine 7x is minus cos 7x divided by 7, the coefficient of x, minus integral of sine x is minus cos x, which makes it plus cos x, and plus c. Question 7, same type. Integral sine 4x sine 8x dx. I can interchange and write it as sine 8x into sine 4x, the bigger angle first, to avoid the negative sign in the formula. Even without interchanging, you can do it. Final answers will be the same. Let us multiply and divide by 2. and use the formula for 2 sine A sine B. 2 sine A sine B, if you remember, it has a minus sign. So we have to write cos of A minus B first and then minus cos of A plus B. Let us use this identity. We get half into integral cos of 8x minus 4x minus cos of 8x plus 4x is 12x times dx. Now we don't have product of two functions, we have only subtraction in between. Integrate each term. Integral of cos is sine 4x divided by 4. And integral of cos is again sine 12x divided by the coefficient, which is 12. I can remove 4 out, so it becomes 1 by 8 times sine 4x, 1 by 3 times sine of 12x, and plus c. Question number 3. We will be using the same method twice because we have product of 3 terms here. Integral cos 2x into cos 4x into cos 6x dx. I will write the bigger angle first just to avoid the negative sign in the formula. Without writing it in this form also you can do. Multiply and divide by 2 and use the formula of 2 cos A cos B. 2 cos A cos B is cos of A plus B plus cos of A minus B. Half into integral cos of, I am using the formula for the first two terms. 6x plus 4x is 10x and cos of 6x minus 4x is 2x. And we have into cos 2x dx. Let's distribute this. We get cos 10x into cos 2x plus cos squared 2x dx. Half into, this half is common to both the terms. I need 2 here. Let us multiply and divide by 2 so that we can use the formula. And half into integral of cos squared 2x dx. Cos has even power. We saw the first method. We have to use the identity for cos squared, which is 1 plus cos 2 theta by 2. Let us use 2 cos A into cos B formula for the first term, which is cos A plus B plus cos A minus B, and use cos square A formula, which is 1 plus cos 2A divided by 2. Therefore, the first term becomes cos of 10x plus 2x is 12x and cos of 10x minus 2x is 8x dx. And the second term, half into integral 1 plus cos of twice of 2x, which is 4x, divided by 2 dx. 1 by 4 is common. Let us take it out. Integral of cos 12x is sine 12x divided by 12. And integral of cos 8x, which is plus sine 8x divided by the coefficient 8, Here I have taken 1 by 4 out. Integral of 1 is x and integral of cos 4x is plus sine 4x divided by 4 and plus c.
Question number 6. Integral sin x into sin 2x into sin 3x dx.
Let me change the order and write the bigger angle first, just to avoid the negative sign. We will multiply and divide by 2. And let us use the formula for the first two terms. We will use 2 sin A sin B formula, which is cos A minus B minus cos A plus B. Half into integral cos of 3x minus 2x, which is x, minus cos of A plus B. 3x plus 2x is 5x into sin x dx. Let us distribute this sin x. We get half into cos x sin x, or sin x into cos x, minus cos 5x into sin x dx. Now to use the formula, again I am multiplying by 2 and dividing by 2. The division by 2 I have written outside the integral. 1 by 4 times 2 sin x cos x is sin 2x, we know, minus, here we will use 2 cos A sin B formula, which is sin A plus B minus sin A minus B. Therefore, this becomes sin of A plus B 6x, 5x plus x, and minus sin of A minus B, 5x minus x is 4x dx. Now there is no product of two functions. We can easily integrate each term. Integral of sin 2x is minus cos 2x divided by 2 minus integral of sin 6x is minus cos 6x divided by 6. Minus of minus will become plus. Plus sin 4x integration is minus cos 4x divided by 4 and plus c, which is equal to 2 is common. 1 by 8 times minus cos 2x plus cos 6x divided by 3 minus cos 4x divided by 2 and plus c. The next type which we are going to learn is integral sine power mx into cos power nx dx. Here we have product as well as we have powers. So we are going to use splitting the odd power method here. Split the odd power. Smaller odd power will be better, but we can do anything. And if m is odd, substitute cos x as t. Whereas if n is odd, substitute sin x as t. This is the method. So one of them is an odd power here. If both are even powers, the method is different.
Write this formula in your formula notebook.
And we have question number 5, which comes under this type. Let's do that. Integral sine cube x into cos cube x dx. So we can split the odd power. Any odd power can be taken. I will split cos cube as cos square x into cos x dx. One power has to be separated. Since we have cos x dx, we will change rest of the function in terms of sine using the identity cos square as 1 minus sine square x. Now see, we have cos x dx and the rest of the function is in terms of sine. So we can substitute sine x as t. Differentiate both sides. Cos x dx becomes dt. Let's substitute. It becomes integral t cube times 1 minus t square cos x dx is dt. Open the brackets and integrate. Integral of t cube is t power 4 by 4 and this is t raised to 6 by 6 plus c, and substitute for t. T is sin x. Therefore, the answer is sine power 4x divided by 4 minus sine power 6x divided by 6 and plus c. It depends. If you have substituted cos x as t by splitting sine cube x term, then your answer will be in terms of cos function. Both answers are correct. I told you, using the identities, we can show that both answers are same. Let us do one question if both the powers are even. Let us do one simple question. Integral of sine square x cos square x dx. Splitting the odd power has to be done, but here both the powers are even. So what are we going to do? We will multiply and divide by 4. It becomes 4 sine square x into cos square x dx. And I can write this as 2 sine x cos x the whole square. And this becomes sine 2x the whole square. And we know the method for sine square, the first method which we saw, the identity. Sine square is 1 minus cos of twice that angle 2x, so it is 4x divided by 2. Take 2 out, so it becomes 1 by 8, and we can integrate these terms. Therefore, the answer is 1 by 8 times x minus integral of cos is sine 4x divided by 4 and plus c. This is how we do for even powers if both are even. This is not in the textbook. Let us continue the exercise. Question number 8. 1 minus cos x divided by 1 plus cos x. Wherever you see 1 minus cos and 1 plus cos, use the identities. 1 minus cos is 2 sine square half of the angle x by 2, and 1 plus cos formula is 2 cos square x by 2. Or we have direct formula for 1 minus cos x by 1 plus cos x, which becomes tan square x by 2 dx. We don't have integration formula for tan square, but we have for secant square. Let us use the identity. Tan square is secant square minus 1. Memorize the identities properly. Don't do mistakes in writing the identities. Now let us integrate. Integral of secant square is tan of x by 2 and divide by the coefficient of x, which is half. And integral of 1 with respect to x is x. plus c. Therefore, the answer is 2 times tan of x by 2 minus x and plus c. Question number 9. Integral cos x divided by 1 plus cos x dx. We know that 1 plus cos x is 2 cos square x by 2. So the angle has been changed to x by 2 in the denominator. So let us change the angle in the numerator also. We can write cos x as, using cos 2x formula, cos 2 theta is 2 cos square theta minus 1. It becomes 2 cos square x by 2 minus 1. Let us separate the terms. The denominator is common to both the terms. Let's divide. It becomes 1 minus 1 by 2 cos square x by 2 dx. This is half. 1 by cos square is secant square. And we know the integration formula for secant square. Integral of 1 is x minus half into integral of secant square is tan x by 2 divided by the coefficient of x. This half and this half will get cancelled. Therefore, the answer is x minus tan of x by 2 and plus c. Question number 12. Integral sine square x divided by 1 plus cos x dx. Sine square can be written in terms of cos square, which is 1 minus cos square identity. And now numerator can be factorized using a square minus b square formula. A minus b into a plus b, so that the common factor 1 plus cos x could be cancelled. It becomes so easy to integrate. Integral of 1 is x minus integral of cos x is sin x and plus c.